Tree planting in the tropics has used only a small fraction of the diversity available in tropical forests. So far, planting has relied on a small set of well-known exotic species. Often these are from untested, poorly documented and narrowly based seed sources. As a result, one tree species from Central America, Leucaena leucocephala, has been at the forefront of community forestry and agroforestry planting for the last 3 decades. In the 1970s, Leucaena was heralded as a miracle tree, was widely promoted by national and international development agencies, and became so popular in some areas that it was the only species planted. But is its miracle tree reputation justified? Tropical forests, with their high species diversity, have provided communities with a wide range of products and benefits for many centuries. The dry forests of Central America contain more than 300 tree species that are known and preferred by local people for different uses. These forests provide crucial support to subsistence farmers and rural communities. As forests are cleared in Central America and other parts of the tropics, this rich source of basic products is disappearing, leading to shortages and land degradation. As a result, farmers and rural communities are turning to tree planting as an alternative source. Choosing which species to plant and what seed source to use are 2 important decisions that ensure success. Leucaena was chosen for several reasons. Firstly, it grows quickly, even on seasonally dry sites, such as here in Honduras, where 1-year-old trees are more than 4 meters tall. Secondly, it's easy to propagate and manage, since it produces abundant seed on most sites, can be lopped or coppiced, and is easily adapted by farmers to many different situations. It also produces several high-quality products. The leaves are rich in crude protein and provide excellent livestock fodder or nitrogen-rich green manure. The wood is an excellent fuel. Finally, Leucaena, a member of the legume family, is able to fix atmospheric nitrogen through association with root-nodulating rhizobium bacteria. With extended use of Leucaena leucocephala throughout the tropics, a number of important limitations became apparent. It was found that Leucaena only grows well on certain sites. For example, in dry areas such as Rajasthan in India, it's slow-growing and is outperformed by other trees such as acacia or prosopis. Leucaena leucocephala shows little drought or cold tolerance and also grows poorly on acid soils. Although abundant seed production was crucial to its widespread adoption and ease of propagation, it also created problems of weediness. In some areas, Leucaena has become naturalized and now forms dense stands, as here in Hawaii. But most important of all, it was found to be susceptible to an insect pest. Heterocilla cubana is a psyllid defoliator, which is native to Central America and Mexico. It spread to Hawaii in 1984, through Asia by 1989, and into East Africa in 1992, causing severe defoliation and loss of production. Communities in Asia that had relied on Leucaena were suddenly faced with shortages of livestock feed and other products. In essence, the miracle tree was becoming a myth. These limitations are partly attributable to the narrow genetic base that has been used. Planting has relied on only one species, Leucaena leucocephala, which is known to be largely self-pollinated. The original introductions were from a few cultivated trees in Mexico and El Salvador, and were likely to be genetically related. Over the last 3 decades, a few self-pollinated varieties have dominated tree planting across the tropics. But why was Leucaena leucocephala spread pantropically, when the close relatives are potentially just as valuable? And why has it been so difficult to locate new genetic diversity within this species? It was spread at least partly by accident. 2 distinct forms are now recognized, the shrubby or Hawaiian type and the giant or Salvador type. These are now recognized as distinct subspecies, Leucocephala and glabrata. The shrubby subspecies was spread as early as the 17th century in Spanish galleons from Mexico to the Philippines and is now naturalized pantropically. In contrast, the giant varieties have been introduced only in the last 3 decades, following research in Hawaii. Back in Mexico, the history of use of Leucaena makes a fascinating story. Several Leucaena species are widely used and cultivated as minor food plants. In central Mexico, Leucaena esculenta, the red-podded Leucaena, is widely cultivated on farms and around settlements. Unripe pods and seeds are harvested and consumed on a large scale in many parts of Mexico. The pods are a common sight in many Mexican markets. Leucaena leucocephala and Leucaena esculenta are the main species that have been used, although others are also consumed and cultivated. In the arid Tehuacan Valley in Mexico, an area famous as a centre of origin for maize cultivation going back over 7,000 years, archaeological investigations of pre-Columbian ruins and caves show that it has been cultivated there for several thousand years, forming part of the diet of pre-Columbian peoples. The prominence of indigenous local names for Leucaena indicates this importance. The city and state of Oaxaca lie in the center of diversity for Leucaena, its name derived from the local Nahuatl name for Leucaena, Waxine. This long history of incipient indigenous domestication means that these species appear scattered throughout the region, and it's now impossible to unravel the true natural distributions of widely cultivated species such as Leucaena leucocephala. It's known that Leucaena leucocephala is a tetraploid. It's likely to have arisen following hybridization between 2 diploid species, but where, when and what the parents were remains a mystery. Without this knowledge, it's proved impossible to locate any natural stands, and only limited genetic variation has been found in the species. This problem shifts the emphasis very much towards other species of Leucaena, which are now under investigation. The Overseas Development Administration of the UK government has been funding a research programme at the Oxford Forestry Institute to investigate the forest genetic resources of Mexico and Central America for the past 25 years. Work on non-industrial trees was started in 1981 by Colin Hughes.
As part of this programme, a project to investigate the genetic resources of Leucaena has been carried out since 1985. In collaboration with botanical research institutes and seed banks in Latin America, with the aim of providing support to tropical countries working with Leucaena. When work started in Central America, we assumed that the genetic resources of Leucaena were already well explored, collected and documented. We quickly realized that several of the most impressive Leucaena species had been overlooked by previous collection expeditions, and that there was still much to find. Our first problem was the identification of species, with no recent taxonomy to guide us through the tremendous variation in the genus. A good example is Leucaena salvadorensis, a species first named in 1928 from El Salvador, but subsequently lumped together with either Leucaena leucocephala or Leucaena shannonii. I first collected botanical specimens of Leucaena salvadorensis back in 1981 in Nicaragua and Honduras. It was clearly a fine tree, highly preferred by local residents for poles and maintained in traditional agroforestry systems. So why was it not more widely known and used in tree planting programs in other areas? Leucaena salvadorensis occurs in Central America only in parts of El Salvador, Honduras and Nicaragua, where recent botanical collections reveal its restricted distribution and infrequent occurrence. Due to its rarity, restricted distribution and confused taxonomy, it was overlooked and neglected in the past. Detailed exploration, mapping, collection and botanical investigation allowed us to build up a complete picture of this little-known tree and re-establish its true identity as a distinct species.
It was also realized that other little-known species of Leucaena were growing in the dry forests of Mexico and Central America in areas where forest cover had been reduced to scattered remnants. The paradox was that the loss of forest cover that was creating the need for tree planting was also eroding the very genetic resources that might be used in tree planting. Several species were found to be under threat. For example, in the degraded dry forests around Chiquimula in Guatemala, Leucaena shannonii, subspecies magnifica, was reduced to fewer than 400 individuals. Depletion of Leucaena genetic resources had clearly reached critical levels. To help reverse this loss and locate new genetic diversity, the Oxford Forestry Institute has carried out new seed collections, which include the complete spectrum of Leucaena species, in the belief that they provide the main way to diversify the material that is available to farmers. But before seed collections can proceed, Colin needs a clear understanding of the taxonomy of the genus. Given the lack of a recently published taxonomic revision for Leucaena, how do you go about sorting out how many species there are and how to identify them?
There are more than 80 names that have been used to describe the species in the past. Botanists relied on a few unreliable characters, such as the size of leaves, to distinguish species. Based on more thorough botanical work, we now recognise 17 species with a further 7 subspecies.
Research started in Mexico City by gathering data from specimens held at the National Herbarium. Other botanical collections were later surveyed, and some 2,500 specimens were examined. The data was then logged onto Brahms, a botanical database. Some species, such as Leucaena salvadorensis, were found to be geographically restricted, easily distinguished, and fairly uniform. Others, such as Leucaena diversifolia, with an extensive distribution throughout the highlands of Mexico and Central America, are much more widespread and are also very variable. Flower morphology and colour vary across the Leucaena diversifolia complex, providing a good example of the sort of problems involved in delimitation of species. Armed with detailed herbarium information, field investigation and collection of botanical material throughout the range of Leucaena has been undertaken. Over 500 botanical specimens have been collected to resolve species names. Several new species, such as this undescribed species from the mountains of Sonora in northern Mexico, have so far been discovered. Botanical material requires careful examination and analysis. Considerable progress has been made towards a taxonomic revision for the genus, and work is in progress at the Oxford Forestry Institute and elsewhere to continue and complete this. So what about these closely related species and their potential? Colin explains.
Leucaena species vary in size and form. Some, such as Leucaena gregii, are small trees. Others, such as Leucaena salvadorensis, form medium-sized trees to 20 metres in height and 70 centimetres in stem diameter. The total distribution of the genus throughout Central America and Mexico spans some 40 degrees of latitude and 2,500 metres in altitude, covering a wide range of environmental conditions. Several species even show cold or frost tolerance. The main diversity occurs in seasonally dry, tropical environments, and some species, such as Leucaena esculenta subspecies metudii, which grows in the semi-arid valleys of Guerrero in Mexico, tolerate low rainfall with up to 7-month dry seasons. Others, such as Leucaena pulverulenta and Leucaena multicapitula, grow in humid tropical conditions and tolerate more acid soils with higher non-seasonal rainfall. These few examples show the clear potential to extend Leucaena planting beyond the limits for Leucaena leucocephala.
Trials in Hawaii and elsewhere indicate good tolerance to psyllid attack in certain species, such as Leucaena esculenta and Leucaena collinsii. Product quality also varies across the species. Several species quickly produce high-density, durable wood and are widely used for construction. In Mexico, the widespread inclusion and protection of Leucaena trees in traditional agroforestry systems is further indication of the very great potential of many lesser-known species in the genus. In order to evaluate and utilise this untapped potential, new seed collections have been assembled by the Oxford Forestry Institute in close collaboration with the national tree seed banks throughout the region. It's taken several years to assemble and document comprehensive seed collections from throughout Latin America. As well as including all the species, seed has been collected from several provenances within species, with a minimum of 30 trees in each provenance in order to maintain a broad genetic base. Seed collections have been carried out from Texas in the USA, south through Mexico and Central America to Ecuador in South America, forming a sound base for evaluation, future seed production and tree improvement. The true potential of this new germplasm can only be evaluated in replicated field trials on a range of sites. In Honduras, a prototype trial has been established using this new material by the Forest Genetic Resources Project, CONCEFOR. Destructive wood biomass assessments of this trial indicate that several little-known species, such as Leucaena macrophylla, perform as well or better than Leucaena leucocephala. These species have the potential to be used in agroforestry, either directly or through interspecific hybridization. Planting of non-industrial trees in the tropics is in its infancy. Much remains to be learned about choice of species and use of appropriate seed sources. While plantations grown for industrial uses select uniform genetic material and can afford the associated risks, it's wrong to expect that a few uniform, high-yielding varieties will adequately meet the complex needs of subsistence farmers. Risk reduction, product quality and timing of production are crucial factors and call for the use of diverse genetic material. It's in this area that lesser-known species of Leucaena offer considerable untapped potential to enhance tropical tree planting. The wise use of new Leucaena species and seed collections will be needed to secure sustainable benefits and finally banish the myth of miracle trees forever.